Hey there, I'm Alan Furstenberg.
And I'm Mark Tucker. Welcome to Two Voice Devs.
Two voice devs. Hey Mark, good to see you again.
It's good to see you too.
It's been continues to be crazy here. So I don't
Oh,
anticipate that slowing down.
yeah, no, it's fun. There's definitely ups and downs. Life can be a roller coaster. Work and development can be a roller coaster. It's just
Yep,
celebrate the highs and don't try to get too, try not to get too discouraged. Look for help when you're in the lows. So
that's an excellent message. Thank you. Thank you for reminding me of that.
yes, so just being a good friend or trying to.
I appreciate it. I really do. Um, so when we were kind of planning out what we wanted to talk about next, we had a huge pile of stuff to talk about.
Yes.
And maybe we'll get to some of it this year. But you sent me an article that Braden Ream of Voiceflow, he's the CEO of Voiceflow, posted a little bit back talking about large action models. And this is a word that came up when we were talking about the rabbit, and when everyone was talking about the rabbit and Rabbit OS and the R1.
Yeah.
So it was interesting to see Braden's take on it. I wanted to thank you for sharing that with me.
Yeah. So I had just checked out today the Rabbit site, and I guess they've sold out on their fifth batch um, of devices. Yeah, it's interesting because they were talking about the AI that's built into the R1 has to deal with large action models as opposed to large language models, and we'll talk kind of about what the differences of those are, and it's evolving and stuff, but. It was just interesting that the goal or the intention of the device was to do things, not necessarily give you information, but actually accomplish different tasks.
Intention. I saw what you did there.
Yes. So the article that Braden wrote is entitled "How Large Action Models Work and Change the Way We Build Chatbots and Agents." So Braden and Voiceflow has been around for 5+ years, and started out as a kind of a diagramming design tool for creating Alexa skills and Google Assistant conversational actions. It's evolved over the years. They've kind of seen where things are going and have modified their tools over time. And this is a little bit about kind of a sneak peek into what their vision of the future for agents and bots or assistants, however you want to call them, is going to go and kind of the role they see Voiceflow playing in that. So it was kind of an interesting take on that from his perspective.
Yeah, what's notable is that, over the past year and a half now at this point, we've slowly seen Voiceflow shift from this Alexa assistant focus
Mhm.
to, and they opened up a little bit to chatbots, to kind of adopting this large language model first approach to things. So bit by bit, they'd been incorporating large language models. And it really feels like now they're just kind of dedicating the product to working around LLMs, which is a dramatic shift.
Yeah, that's true. And also on the Voiceflow side of things, they just come out with a feature called functions, which is very much in this I want my agent to do something realm. And not that we'll really spend a lot of time talking about it, but that did remind me of the work that's happened over the last year in a tool called LangChain, where it can do lots of different things, but one of the things that it can do is work with agents. And and you can define tools and have tools execute and kind of figure out, and there's even, I saw a new library called LangGraph, which I didn't know existed and know much about it, but it's about being able to add cycles into, kind of turns or conversations or like steps into the flow. So those are built on top of large language models, um, but and so that's kind of one approach that's being taken now. But large action models is a little bit of a different concept, kind of parallel idea, like same purpose in the end, I would think, but maybe a different approach.
I mean, I know what, when we talked about the rabbit, what we saw this large action model thing as, and kind of our take on it. And I've seen what Braden just wrote about it. I don't know, how would you describe it? I guess in framing it the same way, or with the framing of what Braden has brought to it.
Yeah, so I think kind of two different concepts I think we need to talk about is he brought up one of the things that agents or bots do is that they, let me see if I can get the three main words he talked about: understand, decide, and respond. So we're going to talk about those three concepts, and then we're also going to talk about the difference between deterministic and probabilistic. So I think, kind of once we get down to the end, talking about kind of about in those two areas, I think we'll have a pretty good understanding of the approach that Braden was talking about. But to kind of get started off, he started talking about a little friend we had in Windows in the 1990s called Clippy. And Clippy would pop up at different points in time and say things like, "Oh, I see you want to write a ransom note." No, that was or it would pop you up in helpful, and there was lots of different memes about what Clippy could help you do that maybe was nefarious. But anyway, if you think about that, there were the inputs that Clippy responded to, or the words or phrases that were inputs. For Clippy was all programmed in. Somebody thought ahead and said, if somebody does this, then we will have Clippy pop up, but ask them about this. And then this will be the step or the thing that Clippy does. So it was all, pre-thought out, pre-programmed, coded so that, if I use Clippy and did the same thing on my machine versus somebody else on their machine, Clippy would do the exact same thing every time, no matter who or where it was. So that is an example of a very deterministic agent. Now you still have the different steps. Clippy needed to understand what the input was, decide what to do, and then give some sort of a response. So those three steps, kind of input, logic, output, is and we've worked with that in different ways, from hard coding it to using different frameworks that I've created, frameworks that you've created, for how, and we talked a lot about different tools or databases or things that we can do, content management systems,
Right. I mean,
we've talked a lot about kind of how we could do that logic and output.
I mean, it seems like, for much of, all the episodes that we've done, we've been talking about how, all of this stuff really boils down to getting something from the user, applying business logic to it, sending something to the user. And, however those three steps are done, that really kind of fundamentally seems like what all applications do.
Yes, yeah, very much so. But with agents, and bots or whatnot, it's we tend towards it's a natural language input, which could be text or speech, and it could be the output could be natural language, sentences, or it could be text to speech, right? So that's kind of how voice gets layered on top of this input processing output paradigm. But the words that Braden used in his I think was very specific was understand, decide, and then respond.
Yeah.
So when I first started creating skills for Alexa using the Alexa Skills Kit or Jovo, there were tools that we would use to define a language model. And in the end, what was really happening was natural language understanding. User would say something or enter something in, and it would figure out which intent would match what your input was. It would surface some slot values or entity values that could be used to help really understand what the user was saying.
See, I would kind of shift how we focus on that a little bit and say that that understanding level is that the system has been taught about certain things that could happen, these intents, or certain things that the user is trying to do. So when the user says something, it is trying to understand it by matching it into one of these intents.
Yes.
Or falling back to a, I don't know,
Yeah.
kind of intent. And that, I think, was, that's a step up from the Clippy method, because these intents had various things that could be associated with them, including phrases, but these were fuzzy phrases.
Yeah.
We weren't saying, this is the exact thing that has to be said.
Yeah. So before like a natural language understanding layer, what you would do is you would take a look at the string and see if you found a keyword, or you'd use regex matching, or you'd do something very clunky. Start to break down tools, try to figure out like the sentence structure, what was the verb, what was the noun. There's lots of different things that you could do, but it was really heavy and coded, whereas NLU is a form of AI. We don't really talk about it in that form because it was kind of like it happened, and then LLMs happened, and we're like, oh, look at AI.
Well, and that's it, is that this is, I mean, one of the important things is that this was an early stage that led to what we now use as LLMs.
Yep.
But it still was this fuzzy matching notion based on, not on the exact words matching, but on kind of the concepts matching.
Right.
The biggest advantage is, you could train it and then it would respond to it very quickly.
Yes.
Once it was trained on a dozen sample phrases, it could deduce other sample phrases and match those based on that pattern that we had already set up.
Yeah, and the context of your bot would say this bot is to do a certain thing. It's to order food, or it is to figure out the weather. And so you might have anywhere from 5 to 40 intents, with each intent having various utterances, and maybe some of those are just simple intents, and some of them had slots, like what's the weather in Phoenix tomorrow, so that might be 2 slots, and so there's, but you're right. So natural language understanding is a form of AI that uses pattern. It's like this sentence closely matches the kind of the sentence structure that I was trained on.
Well, I think it's important that it's not just matches the sentence structure that I was trained on, but it did start to get into the semantic understanding of what it was. It wasn't, not quite to the same degree that the LLMs they do currently.
Yeah.
But if I could create sentences that were close enough that it would do matching, and close enough was pretty fuzzy in a lot of, if I had said something like, what's it like outside?
Yeah.
It might have matched what's the weather outside, or what's the weather.
Yeah, but I think it's important on NLUs is that the relationship, the kind of the semantic relationship between other words was because I put in a list of synonyms, or I did sample utterances. It wasn't necessarily going to make a leap between concepts, and you might have to put those synonyms and those concepts
that's
together.
Fair. No, that's fair. I mean, it wouldn't make the leap between some concepts and others. To use my same example, it wouldn't necessarily match is it raining out to what's the weather.
Yeah, unless you trained it to do
you trained it to do that. Yeah. But it might have made the leap to, if I had said, is it raining outside? It might have made that connection to what's the weather outside, or what's it like outside. So there was a semantic notion with some of the words that we didn't necessarily have to train completely. We didn't have to give it every single pattern that a user might say.
Yeah. So that's kind of the idea where the understanding part was done with some sort of a trained language model, but everything that I've done for the most part for the last number of years that I've been doing Alexa and other voice development is at that point in time, then the coding takes over. And I said, like, when the input is this, then I'm going to start a conversation, and you're in this context of the conversation, and maybe at this point in the conversation you need to ask a follow-up question, or you're gonna or you give them a yes no choice, and then it's keeping track of where you are in a conversation, and it's this turn it's a request response. User says something, agent responds back, user says something, agent responds. But you're keeping track coding wise, very much in a predetermined fashion that says this is when you're at this point in the conversation, then this is what you're going to do, or these are based on these variables or conditions, this is the path that the user is going to go down. And then it's very much so, it's like when you're in that point, then here is what the response is going to be. It's a hard-coded response, or it's a list of potential responses that are similar to give you some variability to make it seem more conversational, but that is also deterministic. So the kind of the way that we've been doing bots for a number of years, primarily for these major platforms, is natural language understanding for the understand part, deterministic for the decide part, and deterministic for the respond part. So that's kind of how we've approached it. And then LLMs came along, and what LLMs are really good on is that they're trained on so much content, so many sentences, that you give it a phrase or start to say something, and it will figure out, generate what should come out next. And so that maps really well to the respond part. But then you get into trouble. Well, if you don't pin that down to something like a list of frequently asked questions or the content of your website or something like that, then it can start hallucinating about what it'll just happily tell you some story about some nonsense. If it doesn't really know what it's generating, it's just generating.
It's generating probable next words.
Yeah,
that
probable
sound
next.
good.
Yeah, that sounds good. It says, hey, based on what I was trained on, this is here's like 10 or more options of what I could say next, and I think I'm gonna go with this one today or right now, right? And so it's very much not deterministic in the fact that if somebody says the same sentence, they may or may not get the same response back from an LLM. Whereas that doesn't seem to be the case with how NLUs are trained. If multiple users give the exact same input, then they'll get the exact same intent and values back. There's nothing else that
it will trigger the exact. It should trigger the exact same intent.
Yeah, it should.
The response depends on other things, but it's still a deterministic response.
It should come back with the exact same intent and slots based on any given input. So it's more constrained, and NLUs are more constrained in the value that it gives back, which are the intents and slots, than an LLM, which generates things. So
okay. So how does this fit into LAMs?
The concept of large action models is that it fits into the decide part. It fits into the and it might even fit into the might take over the NLU part, but it's figuring out what the user has said and figuring out what, based on what the bot is, what steps it needs to take to do those things. So like if I want to order some items, it might tell me about the specials. I would give the input. It might ask me from additional things that I might want to buy based on the thing that I ordered, some accessories to it. But it's actually, in the end, it's collecting information, it's taking actions, it's making API calls, it's reading values in the data store, it's putting values in the data store, it's breaking a problem into the steps of the information that it needs to accomplish the steps, and then it executes the steps.
I guess the question I have from there is, how does this relate to large language models? What are the lessons that we learned from LLMs that we can apply to LAMs?
Yeah, and this is the part where I think it's still being figured out. So there is no model that I can go to that says this is a large action model and how to use it. But I think fundamentally the idea is that large language models are trained on lots and lots of sentences and text, or code, or images, depending on what the LLM does, right? But let's focus on an LLM that really just does text. Whereas a large action model would need to be trained a little bit differently. It would need to be trained or optimized or focused or however it is, so that it figures out how to say, here's the list of the things that the bot can do. Here's a description of all the APIs it can call. Here's the inputs that the APIs can make. Here's all this information, and figure out how to break a bigger problem, like order something, into all the steps that it would take to order.
So, I mean, but in many ways, to me, that sounds like we're basically saying, here are all of the intents, and here's what the intents do. You just get to figure out what the user said just triggered an intent.
Yeah, so I think in some
that
ways,
seems like the first step here, and I'm not sure how big a leap that is.
yeah. Yeah, because I've used large language models to try to do the same thing that NLUs do. And like here's the language model that I would have passed to the model is behind the scenes. And in a lot of cases, it worked okay. In some cases, it got lost on and tried to find something else, or I didn't give it enough clues along the ways as far as what it did. Plus, it had the disadvantage of is it took a lot longer for the LLM
Yes.
to try to figure out what you said and match it to an intent than an NLU would.
Yes.
But one of the advantages of the LLM over the NLU is it had connections between words and things that I didn't have to train it to figure out. I didn't have to put in every utterance that I wanted or a list of synonyms. It kind of just knew semantically, just because of the vast amounts of data that I was trained on, where to make some connections that I didn't necessarily have to do. So I see how that, I have tried to use LLMs to do some of the things that NLUs can do, but have really come to the conclusion that at least right now, NLUs are great doing what NLUs do, and that LLMs are not optimized to solve that problem yet. And so I could see a series of LLMs being built that were optimized, faster, and handled that type of limited input, and was a lot better at giving you, the intent and slots that you needed. But that's the first step, right? So the middle step, the decide step, is the trying to figure out which steps need to happen, break a bigger problem into smaller problems, figure out which functions need to be called for the smaller problems, and then do those things until to the point that everything's been resolved, and then do some sort of an output. But I've also tried to solve, or some people have also tried to solve that same problems with LLMs and this agent structure that you can use with LangChain or other things. So is it possible that LAMs is just a progression of LLMs with better tools to do the decision part? Or could it be that LAMs are going to be large models that are trained specifically on actions and understanding problems and breaking problems down?
Well, and I feel like that's kind of the challenge that I'm trying to wrap my head around.
Yeah.
Is how much of the way Braden talks about it is he says, we're going to have decision trees. We're going to have these intents and these intent flows still, but they're going to be high level stuff. So if you're ordering something, you're going to say, okay, from a high level, you want people to browse and order stuff, and then you want people to pay for it, and then you want people to select how it's shipped, or something like that.
Yeah.
These are high level flows. But the details of each of those, it's going to kind of leave up to these LAMs, who will know that, when browsing and putting stuff in a cart, you've got functions for searching for items and functions for adding something to a card and I don't know what else, but
Yep.
I feel like what's challenging to me is just how many, it's not like these have a tremendous number of combinations to them. There are certainly some things that, well, I don't know. The more I think about it, I'm like, well, okay, if I'm trying to order something, I might say, maybe I'll want that, or an example that from the early days of actions on Google was, I want something to eat that is warm and made out of this vegetable and that I can cook in under 30 minutes, and you have this long run-on sentence.
Yep.
At what level can you make it so I don't have to give it a long run-on sentence, but I have more of a conversation?
Yeah.
My initial reaction is somewhat pessimistic about these, because I feel like they're just going to deteriorate into inferior versions of intents until we really start digging our way out of it. I mean, right now we've got large language models that support things called functions, where you say something and it returns a JSON structure with a defined function name and defined parameters. And gee, if that doesn't sound like an intent, I don't know what is. But I've also seen interesting things where, you say something and it'll return back that data structure, expect the values as if this was a function call, and then keep repeating that through its defined functions to get to an outcome. And that's kind of agent-like.
Yeah.
So I don't know. I'm dubious that whether people have really thought through some of how this really should work.
Yeah, it seems like there's definitely this need for something in the middle. And I don't know that we necessarily know quite how to get there yet. And how much of this stuff is going to be pre-trained so that it's generic for any type of list of problems to
Right.
break it down into steps. But there's got to be a part where my bot needs to call this particular API because this is the vendor that we use for, for processing credit cards. Or
Right.
this is the service that we use to give us the list of items that are for sale today. Or, there's got to be a way. It's kind of like and that's got to be the deterministic part of a bot, because these are exactly some things that have to happen. There's no like wiggle room. It's not like, oh, I want to use,
Well, right. And that I think is what Braden was referring to as the high level concepts. I think the other thing that still needs to be deterministic are the responses. Because I'm suddenly reminded of the scene in Miracle on 34th Street, where the kid asks for a toy, the Santa who's the Santa's there, and he says, well, you can get it here, but it's better if you go across the street to Gimbel's. And that works well for a movie, and it works well at Christmas. But I think any agent that is given that much leeway, you're going to shut it down as quickly as you can for business purposes.
It's going to be interesting because with models, they tend to be, probabilistic, and I guess depending on how trained, like how focused or trained that you make it, then maybe the ability for it to hallucinate is very small. But right now, LLMs is not that. And you don't want to give it the ability to calculate things wrong, or like, oh, I just charged your credit card, but I hallucinated and now it was $1 million coffee.
Right. And at the same time, though, if we've narrowed down the hallucinations, then we could also just pick the responses ourselves.
Yeah, you could pick the responses, but I also think like right now with LLMs, and why they might be preferable than hard coding responses, is that you could still, as part of the prompt, say this is the output, this is the the items that they bought and the costs and the total costs and all this other stuff, and you could say generate a response. And when we're at the point in time where latency is not an issue, which I still think it is an issue with LLMs, that it could make that job easier. You could kind of give it instructions that in this case, the thing that you want to output is this, and here's the data. And so it can generate it, and it might make it easier on the response side of things.
But here's the thing. At one point in the past year, I tested a burger ordering LLM system, tried building one. And I did that for the responses. And inevitably, the responses all ended up being one of three responses. Okay, I've added that to your order. Okay, we've got,
yeah.
Even though it was supposedly non-deterministic.
Yeah.
It kept using the same responses over and over because statistically, those ended up being the most likely responses.
Yeah, I can see that. And that might be the case for small, kind of more conversational things. But if we were to think about maybe a system like the Star Trek computer, where you say blah, 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 and it goes and does some things, and then it gives you a summary of it, then maybe that is a situation where the computer is generating a response that's more helpful to us than we could hard code or handcraft.
But if we think about so let's use the Star Trek computer as an example again. But if we think about some of the things that we frequently asked the Star Trek computer to do, or that the captain would frequently ask the crew to do, maintain standard orbit, fire weapons pattern Alpha 9.
Those are sounding like actions.
Yes. Well, that's what we're talking about here, are actions.
There are some where you're like, evaluate, search the databases and come up with a summary for all cases where such and such
but that's
happened,
not really That's not really an action. That's a that's a pattern match. That's a little different.
So, and the part that I want to bring up too is that I think it also kind of determines is based on what you want your bot to do. If your bot is a bot that's answering questions like frequently asked questions or information about your website, I think there's not necessarily a lot of logic in there other than summarize, find, this is my input, find things that closely match that, and summarize or pick the best responses and give me an output. So I think that those types of chatbots are easier to do today with either the NLU tools or the LLMs that we have. But I don't know that what we have today for large language models is going to be the answer for trying to figure out this action part. It may end up being that. I don't know. Right now, LLMs can do images, and it can starting to do video, and it's starting to do.
Come on, we talked about video last week.
Yeah, so maybe this action functionality is something that's going to just be built into large language models as well, or maybe there's going to be a different type of model that's specific for actions, that's trained a little bit differently, and that's used in a certain way. And maybe if it's more focused to do just that thing, maybe it will be faster, and you'll get those 100 milliseconds response times versus the 3, 4, 5, 10-second responses.
Well, and we did talk about this. Last summer, Noble and I talked about OpenAI functions when they first came out, and we related them to intents. And maybe that's going to be the big bridge. And right now, one of the big things in Gemini are Gemini's functions and how they work. Maybe that is the bridge, but I feel like we're still, I don't know. They're almost still being treated as intents. And I don't think we really understand how to build these actions yet. And I think that maybe what Braden was trying to get at is that, our next tools need to address that more. He was talking about it in terms of, we're just going to be building employee manuals for our bots. I'm not sure how good that is, because, the next step is, okay, if you look at call centers don't have employee manuals, they have scripts, which is intense, which is, what we're just trying to get away from. So I don't know. I think Braden's onto something here, but I think Rabbit is onto something here. I'm just not quite sure anybody, including them, knows exactly what.
Yeah, it's definitely something that I think is a problem that needs to be better solved than it is today.
Yeah.
And hopefully we'll start getting some of the same focus that large language models have. I think in some cases, I feel like LLMs have been like, oh, we have LLMs. Does it fit in this box? Oh, no, not so well. Does it fix in this box?
Well,
No.
that's funny because I feel like right now we have LLMs and we've got people saying, does it fit in this box? Who cares? It's an LLM. Of course it fits in this box. We'll make it fit in this box.
Yes. So yeah, just because you build on top of an LLM doesn't mean necessarily that the thing you're building is a good use of LLMs.
Right. I think it's important to really realize that while these models seem like they can do everything, they don't necessarily, it's not that they should do everything. There are things that other traditional logic-based systems can do much better, faster, and cheaper. Maybe that's old-fashioned thinking, but I just worry that we forget that sometimes. And I feel like that's when Braden was talking about, the employee handbook, I'm like, these systems are good. I'm not sure they're ever going to be that good.
Yeah, it'll be interesting to see where things go, because I don't know. It's kind of one of those things that, like, how to draw a bird. You draw, a circle for the head, and you draw a circle for the body, and then the next step is draw the rest of the bird. Right? We still need to figure out what those other steps are.
It's interesting stuff. It's always interesting, and it's going to be interesting to see exactly the role that developers play in this.
Yeah.
Where are we defining the business logic, and how do we define it as developers? Is it just an employee manual, or is there something more solid to this? And I think there needs to be something more solid.
Yeah.
But
and I don't think just because LLMs are out that you should throw NLUs out the door. I think there's, for a number of systems and other uses, LLMs are great. And they're, you may need to, for the time being, do the middle logic part in a deterministic, programmed fashion. And then maybe or maybe not use some sort of a model for generating the output.
And I think that's okay. I think certainly price-wise, I would expect NLUs to be cheaper right now.
Yeah.
So it makes sense that when you have certain steps that can be clearly defined, certain intents that can be clearly defined, use the NLU and define them. And when you don't, that's when you start falling back on using your LLMs to understand the logic. And I think this is what we're seeing in tools like Voiceflow and Dialogflow are doing these sorts of things.
Yeah, because if you look at just a pure, how much is this going to cost for this application? If I do everything with LLMs, it's going to be a lot more expensive than if you use NLUs for the input part.
Right, because these large action models are taking multiple steps through the AI model. And if each step costs, even if each step costs fractions of a penny, you go through it a bunch of times and it starts adding up, and you have a bunch of people doing this a bunch of times and it's really adding up.
Yeah, just think about all the tokens that you'd have to use for the step breakdown and the whole processing decision part.
So I think it's interesting stuff. I'm still dubious, but little bit of skepticism is good. Love to hear what everyone else thinks. As always, you can reach out to us on social media or leave comments below. And this will be a topic we return to, I'm pretty sure.
Yeah.
Another time on Two Voice Devs.
Two Voice Devs. Take care, Alan.
Take care, Mark. Have a great week.
All right, you too.